Okay, Module 3, Lesson 2. So today we're going to look at percentiles and density curves. This is going to relate to our z-score. So we will, let's dive into the lesson. And I do want to talk about this as well. Actually, I'm going to start there. This is a review problem. We did this in Unit 1, where we talked about the relationship of our mean and our median. In a symmetric distribution, we have both our mean and our median being at A. So that would mean that our mean and our median would be right in the middle of the curve. So B and C are actually nothing. And if we're talking about mode, this is actually what happens most frequently as well. So in a symmetric distribution, we have A being our mean, median, and mode. When we talk about our second distribution here, in this one right here, all three values would actually be assigned to something. The A would be our mode because that's going to happen most frequent. But if you look at it, our median is going to be where half of our area is on one side and half the area is on the other. A would not be half the area, but B would. B would show about half of our area being here and then about half being here. B would be our median, and C, because this is a skewed to the right distribution, then that means that our mean is pulled to the right. It's pulled to the right, which would be the higher numbers. If you're thinking of a number line, the higher numbers are on the right. So in this one, my mean would actually be higher than our median. So C would be the mean. In this one, the most frequent, our mode would be C, but our halfway point, our median would be at B, and our mean would be pulled towards these lower values because these lower values have an effect on the mean. So our mean would be A, which would be the lower, it's pulled to the lower numbers. That's a great conversation piece. And if I had you guys in my Zoom on this day, I would have had you guys talk about that in breakout rooms. But now getting into the two different concepts that you guys are going to cover for today. Today, you're going to talk about percentiles. I don't want you to ditch your ideas of, well, one way to calculate percentiles is to know where I am in relationship to everybody else in class. So if I know my score and I know everybody else's score in the class, if I did better than 14 people, or my score is the 14th score in the class, then I can do 14 divided by the number of people that are actually in class to figure that out. So in this one, actually this right here, I see an error in it. This should be divided by 25. So, and the math would definitely be divided by 25. So I wrote the wrong number, I did the right math. So let me talk about that in a second. Even I make mistakes, right? So in this problem, what we have is we have 25 math students in a class who took a test. Here are the scores of those students. For this one, we were going to look at who scored an 80 on the test. Well, we have this person scored an 80. Let's say that this is me. I scored an 80. This is mine. I do want to show you one other person though. This person also scored an 80. So I have two students here who actually scored 80s on this test. But I am this one. This is me. The way that I would calculate my percentile before z-scores, because z-scores are going to be another way to do it, but before that, I would actually figure out, well, how many people scored lower than me? So where am I at in relationship to everybody else in class? What percentile am I at? So I would count all the ones that are at 80 or below. So I have 1, 2, me, I'm going to count that one, 1, 2, 3, 4, 5, 6, 7, I'm counting that other person, 8, 9, 10, 11, 12, 13, and 14. So I am the 14th value in the class, or I scored as well as or better than. That's how we always say it. I did as well as or better than 14 out of the 25, which would put me in the 56th percentile. So again, this number right here, ignore that. That should be a 25. 14 out of 25 is 0.56, which means I'm in the 56th percentile. I did better than average because I'm above that 50% mark. Okay. So you can see that I've done that for a couple more. Like if I got a 72, well, that's lower than average because actually only 2 people I am at this 72 right here. Only one person did worse than me, which is the value of 67 right there. So there's only two values. I was like the second lowest in class. So 2 divided by 25 is 8. I'm in the 8th percentile, which obviously on a test, I wouldn't want to be that low. If I got an 89, there were actually only 2 people that did better than me. I'm in the 23rd out of 25. I'm in the 92nd percentile for test takers in my class. You can imagine that this is going to be very difficult to do if I had any more than 25 values. Even 25 values, it was a little bit difficult. But with more values, let's say I had 300 values, calculating a percentile in this way is going to be challenging. So what we're going to do is we're going to use z-scores instead and relate it to the mean like we did yesterday. So I do want to show you there are other ways to calculate percentiles in this class. We're going to probably use z-scores more than anything because it goes faster. Okay, the last concept you have today is the idea of a density curve. So when we have normal distributions, what we're going to do is we're going to just generalize them. You guys kind of saw me doing this in Unit 1, where when I was asked for shape, for people to cuss, right? When I asked for the shape of the distribution, I kind of drew a line around my data and I was like, well, this is about symmetric or this is skewed. Well, a density curve is exactly that. It's drawing a line around the data and then kind of covering it up, coloring it all in and saying, I'm going to use this density curve to describe this data. We're going to particularly do this with any kind of symmetric data so that we can say, well, this is symmetric, so we're going to just color it in and we're going to use what's called a normal distribution to describe this data. So this is kind of like the first step in being able to do that moving forward for the rest of the year. Normal distributions are going to be used in here a lot. So understanding that that comes from data being symmetric, we just kind of draw a shape around it and we say we're going to normalize this data. So a density curve has a couple of components though. It has its shape. It's going to just be like an overall pattern for shape. The big one that I have highlighted here is that when somebody asks, is this a density curve? Because that is a common question. Like if you guys were taking an AP exam, a lot of times they put that question on there. Is this a density curve? And they'll give a curve with some different components. The main thing that we look at for that is that the area underneath this curve is going to be 1 square unit. We're going to use that a lot moving forward. That's what's going to be able to tell us probabilities and percentages. So the area under the curve has to be 1. That's going to be the main thing that we're going to look for. And then everything has to be above the horizontal axis. We don't deal with negative numbers when we're talking about density curves. Okay. Quick little recap on what I just talked about. If you have a symmetric distribution, then the mean and the median are going to be the same. If you have a skew to the left, the mean is going to be pulled to the left. If you have a skew to the right distribution, the mean is going to be pulled to the right. So that's going to show you. Now I'm going to pull away some of the graphs and I'm going to ask you guys to just look at the mean and median and then tell me specifically which one, without graphing them, which one is a skewed distribution. The way you would know that is if our median and mean are the same, symmetric. If my mean is bigger than my median, that means it's going to be skewed to the bigger number, so it's going to be skewed to the right. If my mean is smaller than my median, that means that my mean is pulled to the left, smaller, then that means that I'm going to have a skew to the left distribution. So I will be asking that to compare just looking at the 2 values. And that is it for this lesson. Pop into the next video if you want to see an example of what we're going to do today.